This is the sky over western France. A layer of smoke has swallowed the horizon near Hostens and Jouy as the country faces its most severe wildfire season in modern history. Thousands of miles away, the crisis takes the opposite form. In Pakistan, massive monsoon rains have left entire brick neighborhoods submerged up to their roofs in floodwater. Meanwhile, Hurricane Genevieve exploded in the Pacific, intensifying by 75 miles an hour in just one day to briefly reach Category 5 strength. Tracking these sudden shifts in the Earth's systems is becoming a daily necessity. If you want to follow these global developments with us, hit the subscribe button. These aren't isolated events. When the atmosphere behaves this violently in multiple regions simultaneously, it suggests a broader shift in how the planet handles and distributes its internal energy. Europe is currently the epicenter of the heat crisis. In France, fires around the Gironde region have already burned through 116,000 hectares of land, while Spain is battling the largest single fire in its recorded history west of Madrid. The intensity is so extreme that these blazes are generating their own weather systems. These white columns rising above the smoke are pyrocumulonimbus clouds, thunderstorms created entirely by the fire's updraft. The human toll has been massive. Combined evacuations across France and Spain exceeded 300,000 people at the peak of the fires. The environment became a tinderbox because of a record-shattering heat surge. This data shows a spike in average June temperatures across Western Europe, which crossed the 20 degrees Celsius mark for the first time on record. These numbers are forcing climate forecasters to rethink their heat warnings as temperatures prepared to climb into the low 40 degrees across the southwest and central regions. While Europe burns, Asia is contending with a massive surplus of water. The remnants of Typhoon Noul and a series of monsoon depressions are dragging heavy rain across southern China and India. One specific depression moved across the Indian coast, triggering extreme rainfall and 70-kilometer-per-hour winds as it tracked inland through Odisha and Jharkhand. This has been devastating for Pakistan, where the monsoon death toll has passed 100. Urban centers are flooding as the massive dams upstream reach capacity and release water into already overflowing river networks. The sheer volume of water is overwhelming the landscape. Across the region, more than 600 rivers have risen above their warning levels, a 35% increase over the seasonal average. When we overlaid temperature data onto these river systems, that 35% volume spike aligns with a warmer atmosphere that is capable of holding and dumping far more water than a traditional monsoon cycle. Regional watersheds simply weren't built for this volume. The amplified monsoon is pushing rivers to levels that leave millions of people vulnerable to rapid urban flooding. Even within individual continents, we're seeing sharp localized contrasts. Off the Pacific coast, Hurricane Genevieve is generating waves and rip currents that are reaching all the way to Southern California. Yet on the mainland, the humidity is nowhere to be found. California crews are battling thousands of blazes that have already scorched nearly 200,000 acres this year. On the East Coast, the element flips again. New York and Newark are bracing for up to 5 inches of rain, with hourly rates high enough to trigger flash flood watches. The Southern Hemisphere is seeing its own anomalies. In South Africa, a single storm system is producing heavy coastal rain and significant snowfall across higher elevation regions simultaneously. From burning hillsides to snow-covered peaks and urban floods, these localized extremes show that the global weather cycle is operating well outside its traditional balance. To understand why this is happening, we have to look past the individual disasters and view the Earth as a single, connected engine. The first driver is a rising global temperature baseline. This heat acts as an amplifier, pulling more moisture from the ground to fuel droughts and wildfires, then storing that moisture in the air until it falls as extreme rain. A strengthening El Niño is the second driver. This heat pulse redirects trade winds, shifting where rain and drought occur. Interacting with the warmed baseline, it fuels these extremes, aligning heat to Europe's fires and Asia's floods. These record-breaking events are no longer freak occurrences. They represent the emergence of a new planetary baseline, one where the extremes of fire and water are the standard we have to adapt to.